Hi everyone and welcome back to the channel. In today's video we'll explore how to derive the equation of a generic line in the Cartesian plane. Unlike lines that pass through the origin or run parallel to the axis, we'll focus on lines that intersect the y-axis at some point Q and have a defined slope m. Let's get started. We want to derive the equation of a generic line in the plane that does not pass through the origin and is not parallel to either of the Cartesian axes. To do this, we will use the approach based on translating the reference system. Let Q, 0Q be the point where R intersects the y-axis, and let tau represent the translation that moves the origin to point Q. Therefore, tau will be moves x to capital X and y to capital Y plus Q. This is capital Y and this is capital X. And let tau to the minus 1 the reverse translation. So the reverse translation will bring back capital X to X and capital Y to Y minus Q. In the translated system capital X, Q, capital Y, the line R passes through the new origin Q, and therefore it has the equation capital Y equals M capital X. Applying the inverse translation, which is tau minus 1, gives us the equation of R in the original XOY system, where R no longer passes through the origin. So here we apply tau to the minus 1, so capital Y becomes Y minus Q, and M capital X becomes MX. And this is Y equals MX plus Q. This is the equation of a generic line in the plane, where M is the angular coefficient or slope and Q is the y-intercept, representing the ordinate of point Q where the line intersects the y-axis. This equation is known as the explicit form of a straight line equation, or the equation of a linear function. By observing the figure, we can see that y equals mx plus q, which is the line here, R, represents the set of points whose ordinates exceed those of the corresponding points on the line y equals mx, which is passing through the origin, by q. So this is q, this is q, this is q. Now let's put things into practice with a short exercise. We consider a line R passing through points A, 2, 3 and B, 1, minus 2, we want to find the equation of R. R is a generic straight line, and therefore its equation will be y equals mx plus q. We also know that points A and B must satisfy this equation, and therefore it's possible to write a system of equations by substituting the points inside the equation itself. So in the case of A, we will get 3 equals 2m plus q, and for B it's minus 2 equals m plus q. So m equals minus 2 minus q, and then we can substitute in the first equation minus 2 minus q plus q. 3 equals minus 4 minus 2q plus q. M equals minus 2 minus q. 7 equals minus q. So basically it's q equals minus 7, and therefore m is minus 2 plus 7. So finally we have q equals minus 7 and m equals 5. So we can write the equation as y equals 5x minus 7. Thank you for watching this video. I hope it was helpful. If you'd like to learn more about this topic, please let me know in the comments. Keep practicing and see you next time.